Okay. So let us start. Okay, so we have completed some 10 questions in the previous class. Okay, so we'll continue with the next questions. Okay, so this was the last question which we have seen. Okay, so let us start with the 11th question. So the 11th question is, while charging the lead storage battery, okay, when you charge the lead storage battery, A, PbSO4 is on the cathode is reduced to Pb, B, PbSO4 and anode is oxidized to PbO2, C, PbSO4 on anode is reduced to Pb, and D, PbSO4 on cathode is oxidized to Pb. Okay, so lead storage battery, when we are discussing about lead storage battery, so you need to know about the reactions. Okay, what reactions are occurring when the battery is charging. Okay, what is the charging and discharging reaction, so that you have to know. So what is happening at anode and what is happening at cathode. So let us see the reactions. Okay, Lubna has answered it as A. So just so when the lead storage battery, okay, so when you are charging the lead storage battery, so at anode, okay, at anode is your PbSO4. Okay, so at anode what will happen, there is a reduction. Okay, reduction will occur at anode, so it will gain electrons, 2 electrons, giving you Pb plus 2 plus SO4 minus 2. Okay, so this is at anode. And at cathode, what are the reactions occurring? At cathode, your PbSO4, okay, your PbSO4 will react with the water to give you lead oxide. Okay, lead oxide plus sulfate plus 4H plus ions, okay, plus 2 electrons. So your oxidation occurs. Okay, so what happens at cathode? Oxidation occurs. So PbSO4 plus water giving you lead oxide plus SO4 minus 2, 4H plus ion plus 2 electrons. So when you write the overall reaction, okay, what is the overall reaction? So the overall reaction will be PbSO4, okay, PbSO4 2 times. Okay, there are 2 times PbSO4 PbSO4, okay, 2 times PbSO plus 2 water, H2O. So whatever is on the left hand side, please write it down on the left hand side. Then Pb, okay, Pb, then plus PbO2, okay, plus H and SO4 will combine to give you 2H2SO4. Okay, so this is our overall reaction. So what is happening? So our PbSO4, okay, is on the anode. It is reduced to what? It is reduced to Pb. So our answer is option number C. PbSO4 on cathode is reduced to Pb. No. PbSO4 on anode is oxidized to PbSO2. No. At reduction, what is happening? At anode, your reduction is occurring. So option number C is the correct answer. Okay, understood? Option number C is the correct answer. Okay, so you can see the reactions at anode and cathode reaction. So at anode, reduction occurs. Reduction means what? Gain of electrons. And this cathode, this is what? At cathode, oxidation occurs. Oxidation means what? There is a loss of electrons. Okay, electrons are given up. So you can see that PbSO4 at anode, it is undergoing what? Reduction. It is getting reduced to Pb plus 2. Okay, so our answer is option number C. Okay, our answer is option number C. I hope you have got it. So you need to know the reactions. What are the reactions occurring at anode and cathode? Okay, let us go for the next one. In H2O2 fuel cell, okay, in hydrogen oxygen fuel cell, the reactions occurring at cathode is. So what is the reaction occurring at cathode? So this is the question. Okay, so here when you see the okay, so these all fuel cells, whatever you are studying, okay, hydrogen oxygen fuel cell, so these all, and then lead storage battery, all these batteries, okay, so these all you need to know the reactions are very important. Okay, so what are the reactions occurring? So in hydrogen oxygen fuel cells, so what are the reaction at anode and what are the reaction at cathode? So please note it down. At anode, the reactions are 2H2, okay, 2H2 plus 4OH minus aqueous, okay, giving you 4H2O plus 4 electron, okay. So, and at cathode, oxygen plus H2O plus 4 electrons, giving you 4 OH minus. Okay. So here, what is happening here? There is loss of electrons, so oxidation, and at cathode, reduction. Okay. So now here, what is the overall reaction? So at overall reaction, write the overall reaction. So it will be 2H2. Okay, 2 times H2O2. So 2H2 plus O2, giving you 2H2O. Okay. So this is the overall reaction. So this is the overall reaction. This is the overall reaction. So hydrogen plus oxygen will give you H2O. So here, what is happening? Just see what is the reaction occurring at cathode. So cathode, what is the reaction occurring? O2 plus water plus 4 electron, giving you 4 OH minus. Okay. So it is option number, which is option number A. Yes, very good. Sri Varuni has answered. Dubna has answered. Okay, so it is option number A. Okay, so please note it down. So whenever, so you have to study thoroughly the reactions. Okay, what is the cathode reaction? What is the anode reaction? So these all things you have to know in this batteries and the fuel cells. Fine. Let us go for the next one. Which of the following is incorrect in a galvanic cell? Which of the following is incorrect in a galvanic cell? A. Oxidation occurs at anode. B. Reduction occurs at cathode. C. The electrode at which electrons are gained is called cathode. D. The electrode at which electrons are lost is called cathode. Yes. What is incorrect about the galvanic cell? What is incorrect about the galvanic cell? What is incorrect about the galvanic cell? Theory based question. Okay, so you need to know the theory behind it. Yes, galvanic cell. What is galvanic cell? Okay, I've got two answers. Sri Varuni and Dubna has answered it as D. So what are galvanic cells? So galvanic cells are the electrochemical cells, right? Which produces the electrical energy. It is a spontaneous reaction where oxidation and reduction occurs, right? So your storage battery, storage cells, they are example of galvanic cell. So when you are considering a galvanic cell, so at cathode, what happens, and at anode, what happens? Your cathode, okay, at cathode, which is a positively charged, and your anode is a negatively charged. So at cathode, what will happen, and at anode, what will happen? What are the reactions occurring at cathode and anode? Yes, anybody knows? So two answers, I've got two answers as option number uh, D, right? Yes, option number D. What about others? So at anode, okay, at anode, as it is said to be a negatively charged, what is happening at anode? Your zinc will be, if I consider a zinc and copper electrode, okay, so zinc will be present at anode. Okay, so Zn will be converted into Zn plus 2. So there will be loss of electrons. And copper, from copper plus 2, it gives you copper. So there will be what? Here the electrons are lost, right? At cathode, the electrons are lost. So what is the answer? So the at electrode at which the electrons are lost is called as the cathode. Yes, option number D. Very good. Okay. So at cathode, what is occurring? The oxidation is occurring at cathode. Okay. So the electrodes at which the electrons are lost is called as cathode. So oxidation occurs. Oxidation means loss of electrons. So yes, option number D is the correct answer. Very good. Let us go for the next one. A secondary cell is one which A can be recharged, B can be recharged by passing current through it in the same direction. C can be recharged by passing current through it in the opposite direction. D cannot be recharged. What is a secondary cell? What is a secondary cell? What is a secondary cell? So there are two types of cell. You might have be knowing primary cell and secondary cell. So what is the difference? What is a secondary cell? A secondary cell is what? Okay, Lubna has answered it as A, can be recharged. Others, secondary cell, Lubna is saying it can be recharged. Secondary cell, it can be recharged. Okay, but how they are different from the primary batteries? Primary batteries, they are fully charged, and once they are the power this is over, then you are discarding it right after the its use, right? Now when you say secondary cell, so secondary cell, what they do, they store the electrical energy, right, as the chemical energy. So it will undergo the reversible chemical reaction. So if you charge the cell, yes, it can be recharged. But how it can be recharged? It can be recharged by passing the current through in the opposite direction. Okay, if you pass, yes, an electric cell that can be rechargeable and can be used to store electrical energy in the form of chemical energy. Fine. But how it can be recharged? It can be recharged by passing the current through it in the opposite direction. So by passing the current in the opposite direction, it can be recharged. So a secondary cell is one which can be recharged by passing current through it in the opposite direction. So option number C. Okay, the answer is option number C. Yes, Sri Varuni has answered it correct. It is option number C. Fine, let us go for the next one. The amount of current in Faraday required for the reduction of 1 mole of dichromate ions to Cr plus 3 is A, 1 Faraday, B, 2 Faraday, C, 6 Faraday, and D, 4 Faraday. The amount of current in Faraday required for reduction of 1 mole of dichromate ions to Cr plus 3 ions is. So let me write the reaction. Okay, dichromate. So dichromate, if when it reacts with 14, this what? H plus ions, it gives you 2 Cr plus 3 plus 7 H2O. Okay, so how many moles of how many amount of Faraday is required? The Faraday is counted in terms of what? It is counted in terms of the electron, right? So the amount of current in Faraday required for the reduction of 1 mole of dichromate to Cr plus 3 is how much? It is 6. Okay, it is 6. So option number C is the 6 electrons, right? So 6 Faraday. Yes. Okay. Yes. Lubna has answered it correct. Very good. It is 6 Faraday. Okay. So the amount of current required in Faraday required for the reduction of 1 mole of dichromate ions to Cr plus 3 is 6 electrons. So 6 into this. Okay. Faraday amount. So it will be 6 Faraday. Okay. Let us go for the next one. The charge required for the reduction of 1 mole of MnO4 minus to MnO2 is. Yes. The charge required for the reduction of 1 mole of MnO4 minus to MnO2 is. So let me write the reaction. So Mn, MnO4 minus plus 3 electrons giving you MnO2. Okay, so here each oxygen is -2. So -2, this is 8. So this will be +7. Okay, so if I x plus 4 into -2 equals to -1, x 4 to the, yes, it is 7. Okay, so this is +7 and this is +4. So how many electrons? There are 3 Faraday, right? So, so 2 from Mn +7 to +4, there are 3 electrons. So, 3 Faradays. So, 3 Faraday charge will be required to reduce 1 mole of MnO4 minus to MnO2. So, option number, yes, B. Very good. Lubna has answered it correct. Option number B is the answer. I hope this is clear. Okay. So like these questions are asked. So this is a must question. Okay. Like how many Faraday, how many charge is required to reduction of this much to this much 1 mole of okay. So you have to calculate in terms of the charge. Okay. Fine. Let us go for the next one. For a cell involving two electron for a cell involving two electron changes, E naught of cell is equals to 0.3 volts at 25 degrees Celsius. The equilibrium constant for the reaction is A 10 raised to -10, B 3 into 10 raised to -2, C 10 and D 10 raised to 10. So for the equilibrium, you have to calculate the equilibrium constant for the reaction. Yes, how do you calculate? So we have the formula. Okay, so log to the base 10 K is equals to minus G naught upon 2.303 RT, which is equals to NF E naught of cell upon 2.303 RT. So this is at 25 degree Celsius, right? So now your log of 10. Log of 10 is equals to N E naught of cell upon 0.0591, which is equals to what is N? So 2 electron, number of electrons are 2. Okay, E naught is 0.3 by 0.0591, right? So if you calculate this Faraday 2.303 and RT, so the value will be 0.0591, right? So this is equals to, so calculate how much you are getting. You see 2 into 0.3 divided by 0.0591. It will be 10. Okay, it will be 10. So log to the, so if you take the anti-log, okay, if you take anti-log, so K is equals to 10 raised to 10. Okay, so option number D. So you have to get the answer as option number D. So you need to know how to take the anti-log. Okay. Yes, Lubna has answered it correct. 10. 10 is the 10 raised to 10 is the answer. Okay. So when you're calculating the equilibrium constant, so please note it down. This is a formula which has to be used. Okay. Fine. Let us go for the next one. An aqueous solution of copper sulfate is subjected to electrolysis using inert electrodes. The pH of the solution will increase, remain unchanged, decrease, increase or decrease depending on the strength of the current. An aqueous solution of copper sulfate is subjected to electrolysis. So what will happen? What will happen to the pH? So by using the inert electrodes, it is subjected to electrolysis. So what will happen to the pH? So if you see the reactions at cathode and anode, okay. So at anode, what will be there? So water will split into 2H plus 2 electrons plus half O2. Okay, so it will undergo oxidation. Then at cathode, your copper sulfate will be there. So that what will happen? It will take up the 2 electrons and you will get copper. Okay, so if you write the overall cell reaction, So the overall cell reaction will be H2 plus Cu plus 2 plus H2O, giving you 2H plus copper plus half O2. Okay. So as due to as the copper as the H plus ions increases, okay, what will happen? What will happen to the pH? The pH will decrease. Okay, as the H plus ions will increase, what will happen to the pH? The pH will decrease. So option number C is the answer. Option number C is the answer. So as the aqueous, yes, Sri Varuni and Lubna have answered it right. So it is option number C. Okay. So an aqueous solution of copper sulfate when it is subjected to electrolysis using inert electrodes. So what will happen to the pH of the solution? So as the H plus ions here, okay, you can see the H plus ions as it is increases, what will happen? The pH will decrease. So option number C is the answer. So this is a given data, given E naught of Mn plus 7, Mn plus 2 is 1.5 volts and E naught of Mn plus 4 to Mn plus 2 is 1.2 volts. What is the E naught of Mn plus 7 to Mn plus 4? So how do you calculate this? How do you calculate this? So Mn plus 7, okay, so plus how many electrons? It will be 7 and change in electrons from Mn plus 7 to Mn plus 2. It will be 5 electrons, right? So 5 electrons are taken to give you Mn plus 2. So this is a meaning, okay? So Mn plus 7, so it accepts 5 electrons to give you Mn plus 2. So what is the E naught of this? E naught is 1.5 volts. Similarly, Mn plus 4 plus how many? 2 electrons. Okay, 2 electrons. So plus 4 to plus 2. So there is change in 2 electrons. So it is 2 giving you Mn plus 2. So the E naught of this is 1.2 volts. Okay, it is 1.2 volts. So if you calculate delta G naught of this, so delta G naught is equals to minus N F into E naught. So what is minus N? 5 electrons. So 5 minus 5 into Faraday is, Faraday value you put 96,500, okay, into E naught is 1.5. Calculate this. And similarly, delta G naught of this is minus N F and E naught. Minus N is 2 and this is what? Into Faraday is 96,500 into E naught is 1.2. Calculate for both and see what you are getting answer. Lubna has got it as D. What about others? First answer you should get is, after solving this, you have to get it as minus 7.5 Faraday. Are you getting? And this you have to get it as minus 2.4 Faraday. Are you getting same? Yes?
Yes, ma'am. Well.
Okay. Okay. So now next step is what they have asked. You have to calculate the E naught of Mn plus 7 to Mn plus 4. Okay. You have to calculate this. So if I calculate Mn plus 7, so how many is the difference? 3 electrons difference. So plus 3 electrons giving you Mn plus 4. Again, calculate delta G naught is equals to minus N F into E naught. So minus 3 into 96,500 into, we don't know what is the, this what? E naught. Okay, we don't know E naught. So we have to calculate E naught. Now delta G naught. So if we calculate delta G naught, we can also calculate this as E2, 2 minus 1. If we calculate 2 minus 1 from this, can we calculate? Yes. Okay. So this is, we have to get the E naught. So we can't use this. So let us do delta G naught. Okay. So let us subtract. That is delta G naught 1 minus, let us take this 1 and this as 2. So delta G naught 2. And this as delta G3. Okay. This as delta G3. So calculate now. So delta G3 is how many electrons? So it will be minus 3. Okay, minus 3 F of E naught. Right, 3 electrons is equals to minus 7.5 F and minus of minus 2.4 F. Do this and see what you are getting. Okay, Sri Varuni and Anil. Okay, Anil Rathod has got it as C. So minus 7.5 and plus, so it is 7.5 minus, sorry, plus 7.5 plus 2.4, 9.9. This is minus, no. So minus of 7.5, 7.5, and this will be plus. So plus of 2.4. So this will be minus 5.1, minus 5.1 Faraday. Okay, now take this side, minus 5.1 and minus, so this will become that side, so it will become plus 3. So minus 3 F E naught is equals to minus 5.1 Faraday. Okay, so calculate now what is the E naught. Put the Faraday value. So minus 3 into 96,500 into E naught is equals to minus 5.1 into 96,500. Minus 3 into 96,500. So this will be minus 2 is equals to minus 5.1 into 0.50. So this will be divided by minus 2.289,500. So I'm getting E naught as 1.7. Are you getting the same? Are you getting the same after solving? So you have to put the value of Faraday. Okay, so it is 1.7 C. Baby has also got it as C. Lubna, okay, yes, fine. So it is, yes, C is the answer. Yes, very good. Understood? Is it clear? Everybody has understood?
Yes, ma'am.
Okay, fine. Let us go for the next one. So like this, you have to solve. Okay. If an aqueous solution of NaF is electrolyzed between inert electrodes, the product obtained at anode is. If an aqueous solution of NaF, that is sodium fluoride, is electrolyzed between inert electrodes, the product obtained at anode is A, hydrogen, B, Sorry, there was some current issues. Okay. Can you hear me now?
Yes, ma'am.
Okay, fine. Let us continue. Okay, so this was a question. If an aqueous solution of sodium fluoride is electrolyzed between inert electrodes, the product obtained at anode is A, H2, B, sodium, C, O2, dioxygen, and D, difluoride. Okay. So, yes. What is the answer? So if you take a aqueous solution of sodium fluoride, okay, and if it is electrolyzed between a inert electrodes, so what will be the product obtained at anode? So what will be the reactions occurring? Aqueous solution means what? Aqueous solution means water is also present, right? Aqueous solution means water is also present. That is NaF is mixed with water. So what will be the reactions? As we know, at cathode, what will happen? At cathode, reduction will occur, and at anode, your oxidation will occur. Oxidation means again, there will be loss of electrons, and at cathode, there will be gain in electron. So at cathode, your H plus ions, okay, will, and you will obtain a hydrogen gas. And at cathode, your OH minus ions will give you H2O plus O2 plus 4 electrons. So what is happening? So when you are taking an aqueous solution of NaF, that is your sodium fluoride, and you are doing a electrolyzed, okay, between the inert electrodes. So the at anode, your product obtained will be what? It will be a oxygen, dioxygen. Okay, and at cathode, which is a gas liberated, it is hydrogen gas. At anode, it is oxygen. Okay, so at anode, oxygen gas is liberated, and at cathode, your hydrogen is liberated. Okay, so the answer is option number C. Here at anode they have asked, so it is option number C. Okay, fine. Let us go for the next one. The resistance of 0.01 molar HCl solution at 298 Kelvin is 1500 ohms. If the conductivity of 0.01 molar KCl solution at 258 Kelvin is 0.1466 into 10 raised to minus 3 Siemens per second per centimeter, the cell constant of the conductivity cell in per centimeter is. So these are the four options. Okay, so how we are going to solve? So this is a based on resistance and conductivity. Okay, so you have to calculate the cell constant for this. So what they have asked to calculate the cell constant. So which is the formula? I'll give you the formula. So G is equals to, okay, conductivity into the resistivity. Okay, so you have to calculate the cell constant. So cell constant is given as what? Cell constant is equals to the conductivity into its resistivity. Now, what is conductivity given as? Conductivity is given as 0.1466 into 10 raised to minus 3. And what is the resistivity? Resistivity of this is 1500 ohms. Okay, the resistance of 0.01 molar KCl solution is what? It is 1500 ohms. So calculate the cell constant. Cell constant is given as G. Okay, so G is G into conductivity into resistivity. Okay, so calculate. The answer will be in per centimeter. The answer will be in per centimeter. A. Okay. Lubna has got it as A. So you have to get 0.219 per centimeter. Okay. 0.219 per centimeter. Yes. Again, others. Okay, fine. So everybody has got as C, A. Very good. Okay. Let us go for the next one. So remember the formula. Specific, now this is about specific conductance. You have to calculate the specific conductance is given. You have to calculate the molar conductance. So specific conductance of 0.1 molar HNO3 is 6.3 into 10 raised to minus 2 per ohm per centimeter. The molar conductance of the solution is. So how to calculate the molar conductance of the solution? So the formula to be used here is molar of conductance is given as into conductance into 1000 into molar. So what is the conductance? Specific conductance. Specific conductance is 6.3 into 10 raised to minus 2 per ohm per centimeter into 1000 divided by the molarity is what? 0.1. Calculate the specific conductance now. Calculate the specific conductance. Yes, calculate. Okay. What about others? Lubna has got it as C. Yes. So after solving, you are going to get 630 per ohm centimeter square per mole. Okay. Yes. So option number C. Yes. Option number C is the correct answer. Very good. Yes. Okay. Option number C. Next question. For spontaneity of a cell, which is correct? Okay, for spontaneity of a cell, what is correct? So always spontaneity means what? For the cell to be undergoing a chemical reaction. Okay, for a spontaneous reaction to occur. So which is correct? So that time your delta G, okay, delta G should be always negative and your E naught of the cell should be always positive. Okay, so option number B is the correct answer. So for any spontaneity of the reaction to occur, for any cell reaction to occur, so there should be what? Delta G will be always negative and your E naught of the cell, that is your E naught of the cell will be always positive. Okay, so this you have to remember. Okay, it is option number B. So for any cell reaction to occur, for any spontaneity of a cell to occur, your delta G will be always negative and your E naught of the cell will be always positive. Okay. In fuel cells, dash are used as catalyst. What are catalysts? Catalyst will it will fasten the rate of the reaction. So in fuel cells, what are used as catalysts? A, zinc mercury, B, lead manganese, C, platinum palladium, and D, nickel cadmium. Yes. What yes, very good. So platinum and palladium, you know, they are used as a catalyst. Platinum and palladium, they are the catalyst. Okay, what is the role of the catalyst? It will increase the rate of the reaction. So when we are using this platinum and palladium in the fuel cell, okay, in our hydrogen oxygen fuel cell, what they'll do, they will facilitate the reaction, they will fasten the reaction. Okay, they will increase the rate of the reaction of these hydrogen oxygen electrodes. Okay, so it is option number C. platinum and palladium. So what they will do when you are using palladium and platinum, okay, they will fasten the reactions at these electrodes. Okay. Last question. The molar conductivity is maximum for the solution of concentration. The molar conductivity is maximum for the solution of concentration. So these are the four options. So how you are calculating the molar conductivity? So you have to calculate the molar conductivity, that is your conductance into 1000 by concentration C. Okay, we know that molar conductivity is directly proportional to concentration. So lower the value of concentration, higher will be its molar conductivity. Yes, depending on that. So depending upon the concentration. So when you see the concentration, so if the molar conductivity is higher for lower concentrations of the value of concentration. Okay, lower the concentration value, higher will be the molar conductivity. So for which of the molar conductivity will be maximum for the solution of which concentration? So your concentration should be very less. So here which is the answer? The least is 0.001 molar. Okay, so 0.001 molar. If the concentration value is this, then molar conductivity will be highest. So option number B. Yes, Lubna is correct. Okay, so these were some of the questions from electrochemistry. Okay, so we have solved maximum questions. Okay, so any doubts up to here? Yes. So these are some of the questions which we have solved, okay, on electrochemistry. So we'll take few more questions in the next session. Okay, one more session we'll do on electrochemistry. Okay, and then we will take the next. Fine. Okay. Any doubts up to here? Okay, fine. So I'll end the session here. Okay, so we'll meet in the next week. Yes. Thank you.